Now we're going to see what happens when we have non-repeated irreducible quadratic factors in the denominator. As in, if we have something that doesn't factor, a trinomial that doesn't factor, how are we going to set that up? If we have a second degree in the denominator, we need to have a first degree in the numerator. So instead of a constant, we're going to have that ax plus b. That may remind you of y equals mx plus b. That's linear. So we're going to have linear over quadratic. So what do we do first? We factor the denominator, which it really is, except I want you to think about x squared being x times x, and then x squared plus 2. It is quadratic because of the x squared, but that cannot be factored any further. So how do we set that up? Well, first of all, we have repeated linear, so we have a over x, b over x squared, that's the repeated linear from the last lesson, plus, then the other denominator is this irreducible or non-factorable quadratic. What goes on top of here? Cx plus d. Think about, we want a line on top of a quadratic. That's our setup. So here is our equation. We have x cubed plus 5x squared plus 10 over the denominator, and a over x plus b over x squared plus cx plus d. And you might want to put that in parentheses to help you remember that all goes together. Once you have that set up, that's the only thing that's different. We're going to multiply through by our common denominator, which is the original one, to get rid of our fractions. So here one of the x's cancels. Then here both the x's cancels. This is where you really want to put that cx plus d in parentheses, and all you're left with is the x squared plus 2 cancels, and so you're left with x squared. So there is our equation. Now we're going to use our convenient values, and you're only going to get one because remember x and x squared, set it equal to 0, you're going to get the same value. So we're going to have x is equal to 0. So everywhere there is an x, we're going to put in 0. So that's going to be 0. We have 0 plus 2, and then that's going to be 0. And yes, you would put a 0 there as well, but that's going to go away, that's going to go away, that goes away, so we have 10 equals 2b, so b is 5. Now, why are there no other convenient values? Because if you say x squared plus 2 equals to 0, you're going to get an imaginary solution there by taking the square root. So we don't want to have that. So we have no more convenient values. So what are we going to do? We're going to equate coefficients. So again, I'm going to expand this out by distributing. And distributing. So I need A, C, and D. Well, I'm just going to kind of dive in, and I'm going to look at my x cubes. I only have 2 of those. That might be pretty easy. So I have 1x cubed equals a x cubed plus c x cubed. So 1 equals a plus c. Well, that's one equation, but it doesn't tell me a or c. I keep going. So let's look at x squares. So let's see, I have 5b and d. So 5x squared equals bx squared plus dx squared. So 5 equals b plus d. Does that help me? Well, yes, it does, because I know b is 5, so I can replace b with 5 and solve. So I have 5 equals 5 plus d, so that means d is 0. And again, that still hasn't told me A or C, so I'm going to keep going. Let's see, what do I need? A and C. What else is A involved in? Because C only has this x cubed, and I've already used that. So maybe here. How about the x's? So do I have any x's on this side? None. So I have an ax here, and that's it. All right, so for my x's, I have 0x on the left side and 2ax on the right side. So that tells me A is 0. So now I can come back to here and say, well, if A is 0, then C is 1. So I have A, B, C, and D. Again, you could stop there or go ahead and decompose that fraction. We could write it like that, and of course that would go away, and you would just really have 5 over x squared plus x over x squared plus 2. And again, you could check your work by adding these together, and you should get back to there. Let's look at this last example. How would I know that those are quadratics? Well, x cubed minus 1, that's not quadratic. The first step you always have to do is factor the denominator. So you have to remember how to factor those cubes. Might have to go look it up, but this is how it factors. And this trinomial is quadratic. It has the x squared, and it does not factor any further. So I have a linear and a quadratic. So how do I set that up? For my linear, I just need a constant. And for that quadratic, bx plus c, I'm going to put it in parentheses to help me keep it together, over my non-factorable quadratic. That's my equation. Multiply through by the denominator. Again, to get rid of our fractions. Putting bx plus c in parentheses just to make sure it gets all distributed. That's probably a huge mistake most students make, so don't you make it. Now, do we have any convenient values? Yes, we do. As long as you have linear factors, you have convenient values. So I'm going to let x equals to 1. And then, of course, that's going to be 0, so that goes away. So I have 6 equals a times 3, so a is 2. I now still need b and c. So I'm going to take this equation, I'm going to expand it so I can equate my coefficients. So here you just want to FOIL that out. So I have bx squared minus bx plus cx minus c. Now some students go ahead and put the 2 in for the a there, and you can do that. That's fine. I just like to look at it like this. So I need b and c. So b has some x squares and c just has x and constants. So you have some choices. I think I'll go with my x squares first. I have none over here, a and b. So I have 0x squared equals ax squared plus bx squared. That's nice. Why is it nice? Because I know a is 2. So that means b is negative 2. That's pretty good. So I just need c. Well, how about my x's? I have x, 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 and x. Or maybe I should have chosen my constants. Let's look at that one. Let's see, that might have been a constant, and a constant. The constants look a little bit easier, or less, so I'm going to do 4 equals a minus c. I could have done the x's, this just looked a little bit easier. I know a is 2, so c is negative 2. So I have a, b, and c. You could stop right there and that would be fine. Now we're going to look at the repeated irreducible quadratic factors. You don't usually run into these too often, but they do exist. So we're going to use it just like we did the repeated linear, and that you have to write it once, twice, maybe 3 times to go up to the power. So as you look at this, can you factor x squared plus 4? No, you cannot. It's quadratic because of the x squared. It's repeated because think about, what does x squared plus 4 squared mean? It means you have 2 of those. So let's do our setup. So since this is quadratic, I need ax plus b, like that, over the factor to the first power. Then cx plus d, like that, over the same factor to the next power. And then again, if this was to the 3rd, 4th, or 5th, then I would just keep going. But thankfully, I can stop there. That is our setup. Multiply through by the denominator to get rid of our fractions. So I have ax plus b. Please put that in parentheses so you know to distribute. And we're going to have one of those left over. And then here all of that goes away, so I have cx plus d. Do you have any convenient values? No, because you have no linear factors, no convenient values. So let's just dive in and equate coefficients. So I need to multiply this out. Again, we have ax cubed plus 4ax, bx squared plus 4b plus cx plus d. Well, I think I'll start with my x cubes. That looks pretty easy. So what does that say? That 1x cubed equals ax cubed, so 1 is a. All right, what do we want to do next? What about our x squares? We have x squared here, here, and that's it. Wow, that's nice. So I have 1x squared equals bx squared. So 1 is equal to b. Too easy, too easy. Well, now let's look at the x's. I have none here. I have 4ax and cx. So I have 0x equals 4ax plus cx. I can keep going because I know a is 1. So that tells me c is negative 4. Almost done. I just need d. Well, how about my constants? So back to my constants, running out of colors. Let's see, so constants, I have no constants there. Constants are things that don't have x's. There you go. So I have 0 equals 4b plus d. I know b is 1. So d is negative 4. So even though that looks ugly, most of the time they're not too bad. But the hard part about this is that you have no convenient values because you only have quadratic factors to work with.